When working with electrical systems employing NEMA 4X polycarbonate enclosures and rigid conduit, a crucial aspect is ensuring proper grounding and bonding. The question arises whether grounding bushings used on all conduits within pull boxes require a dedicated ground wire running back to the panel board, or if the rigid conduit system itself is sufficient for this purpose. To address this, let's delve into the relevant principles and considerations. Firstly, the primary purpose of grounding and bonding is to create a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. This is essential for safety, preventing electrical shock hazards and minimizing the risk of fire. Secondly, rigid metal conduit, when properly installed with tight connections, can serve as an effective equipment grounding conductor. The National Electrical Code, or NEC, specifically permits the use of metal raceways, including rigid metal conduit, as equipment grounding conductors under certain conditions. The NEC Section 250.118 outlines the types of equipment grounding conductors recognized, and rigid metal conduit is included in that list. However, there are certain requirements that must be met to ensure the conduit's effectiveness as a grounding conductor. Thirdly, all conduit connections must be wrench tight to ensure electrical continuity. Loose connections can introduce impedance, hindering the flow of fault current and compromising the grounding system's effectiveness. Grounding bushings are installed on the conduit ends within the pull boxes to provide a means of bonding the conduit to the enclosure. This ensures that the enclosure is also grounded, and any fault current flowing through the conduit will be safely conducted to ground. Now, addressing the specific question of whether dedicated ground wire is needed in addition to the rigid conduit system, the answer depends on several factors. If the rigid conduit system is properly installed with tight connections and meets the requirements of the NEC for an equipment grounding conductor, it may be sufficient without a separate ground wire. However, there are situations where a supplemental ground wire is recommended or even required. One such situation is where there are concerns about the integrity of the conduit connections over time. Vibration, corrosion, or mechanical stress can compromise the connections, increasing impedance and reducing the effectiveness of the grounding path. In such cases, a supplemental ground wire provides a redundant grounding path, ensuring continued safety. Another situation where a supplemental ground wire is beneficial is when dealing with sensitive electronic equipment. These devices are often more susceptible to voltage transients and electrical noise, which can be minimized by providing a low impedance ground path. A dedicated ground wire can help to achieve this, improving the performance and reliability of the equipment. Furthermore, the NEC may require a supplemental ground wire in certain applications, such as when the conduit run is unusually long or when it passes through multiple sections with couplings. These requirements are intended to address potential impedance issues and ensure adequate grounding. When using grounding bushings, it is essential to ensure that they are properly sized and installed. The grounding bushing should be sized to match the conduit size and should be securely connected to the enclosure. The bonding jumper connecting the grounding bushing to the enclosure should also be sized according to the NEC requirements based on the size of the circuit conductors. In this specific scenario described, where NEMA 4X polycarbonate enclosures are used, it is important to note that polycarbonate is a non-conductive material. Therefore, the grounding bushings must be used to bond the conduit to a grounding point within the enclosure, such as a grounding busbar or a grounding lug. The enclosure itself cannot be relied upon to provide a grounding path. In summary, whether a dedicated ground wire is needed in addition to the rigid conduit system depends on factors such as the quality of the conduit connections, the sensitivity of the equipment being powered, and the requirements of the NEC. If the conduit system is properly installed and maintained, it may be sufficient without a separate ground wire. However, a supplemental ground wire provides an extra layer of protection and is often recommended, especially in critical applications. Always consult the NEC and any applicable local codes to ensure compliance with all grounding requirements. It is also advisable to consult with a qualified electrical engineer or inspector to determine the best grounding solution for a specific installation. Let's consider a more detailed breakdown of the relevant NEC articles to solidify the understanding of grounding requirements for rigid metal conduit systems. Article 250 of the NEC is dedicated to grounding and bonding, providing comprehensive guidelines for electrical safety. Specifically, Section 250.4 addresses general requirements for grounding and bonding, emphasizing the need to create a low impedance path for fault current. Section 250.96 focuses on bonding metal enclosures and raceways, outlining the requirements for ensuring electrical continuity throughout the system. It states that metal enclosures and raceways containing service conductors, grounding electrode conductors, and supply-side bonding jumpers must be bonded together. Furthermore, Section 250.102 provides guidance on sizing grounding electrode conductors and bonding jumpers. The size of these conductors must be based on the size of the largest ungrounded conductor in the circuit, as specified in NEC Table 250.102. Seat 1. This ensures that the grounding conductors are adequately sized to carry the available fault current. Section 250.118 lists the acceptable types of equipment grounding conductors, which, as previously mentioned, includes rigid metal conduit. However, it's crucial to understand that the conduit must be installed in accordance with the NEC requirements to be considered an effective equipment grounding conductor. This means that all connections must be wrench tight, and any fittings or couplings must be listed for grounding purposes. Section 250.130 addresses the use of equipment grounding conductors for equipment connected by cord and plug. In these cases, the equipment grounding conductor must be included within the flexible cord and connected to a grounding type receptacle. This provides a direct grounding path for portable equipment, enhancing safety. When dealing with NEMA 4X enclosures, it's essential to remember that these enclosures are designed to provide protection against corrosion, water, and other environmental factors. However, they do not inherently provide a grounding path. Therefore, grounding bushings and bonding jumpers must be used to establish a reliable grounding connection between the conduit and the enclosure's grounding point. The size of the bonding jumper should be determined based on the size of the circuit conductors, as specified in NEC Table 250.102. Seat 1. It's also important to ensure that the grounding bushings are properly installed and tightened to maintain a low impedance connection. In situations where there are concerns about the integrity of the conduit connections, a supplemental ground wire can be installed inside the conduit. This provides a redundant grounding path, ensuring continued safety in the event of a connection failure. The supplemental ground wire should be sized according to the NEC requirements and connected to the grounding busbar in the panelboard. Let's consider some practical examples to illustrate these concepts. Imagine a scenario where a rigid metal conduit system is used to supply power to a motor in a manufacturing plant. The conduit run is relatively short, and all connections are properly tightened. In this case, the conduit itself may be sufficient as the equipment grounding conductor, provided that it meets all the requirements of the NEC. However, if the conduit run is long or passes through multiple sections with couplings, a supplemental ground wire may be necessary to ensure adequate grounding. Alternatively, consider a situation where sensitive electronic equipment is installed in a laboratory. The equipment is powered by a rigid metal conduit system, but there are concerns about voltage transients and electrical noise. In this case, a dedicated ground wire should be installed to provide a low impedance ground path for the equipment, minimizing the risk of interference and damage. When selecting grounding bushings and bonding jumpers, it's important to choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. This ensures that the products meet the applicable safety standards and are suitable for the intended application. It's also crucial to follow the manufacturer's instructions for installation and maintenance. Regularly inspect the conduit system and grounding connections to ensure that they are in good condition. Look for signs of corrosion, loose connections, or physical damage. Any issues should be addressed promptly to maintain the integrity of the grounding system. In addition to the NEC requirements, it's important to be aware of any applicable local codes or regulations. These may impose additional requirements for grounding and bonding, depending on the specific location and type of installation. Always consult with a qualified electrical inspector to ensure compliance with all applicable codes. Finally, it's worth noting that proper grounding and bonding is not only essential for safety, but also for the reliable operation of electrical equipment. A well-grounded system can minimize voltage transients, reduce electrical noise, and improve the overall performance of the equipment. Therefore, it's important to invest the time and effort necessary to ensure that the grounding system is properly designed, installed, and maintained. To further clarify the sizing requirements for grounding conductors, let's delve into NEC Table 250.122. This table provides the minimum size of equipment grounding conductors for grounding raceway and equipment. The size of the equipment grounding conductor is based on the size of the overcurrent protective device protecting the circuit. For example, if the circuit is protected by a 20 amp circuit breaker, the minimum size of the equipment grounding conductor is 12 American wire gauge or AUG copper. If the circuit is protected by a 60 amp circuit breaker, the minimum size of the equipment grounding conductor is 10 AWG copper. It's important to note that these are minimum sizes, and larger conductors may be required in certain situations, such as when the conduit run is unusually long or when the equipment is particularly sensitive to voltage transient. When using aluminum conductors for equipment grounding, the NEC requires that the conductor size be increased to compensate for the lower conductivity of aluminum compared to copper. Specifically, Section 250.122. B states that the equipment grounding conductor shall be aluminum or copper-clad aluminum and shall not be smaller than required by Table 250.122, but it need not be larger than the circuit conductors supplying the equipment. When using a metal raceway, such as rigid metal conduit, as the equipment grounding conductor, it's important to ensure that the raceway is electrically continuous throughout its length. This means that all connections must be tight and free of corrosion. Any fittings or couplings used must be listed for grounding purposes. In some cases, it may be necessary to install bonding jumpers around conduit couplings or other discontinuities to ensure electrical continuity. These bonding jumpers should be sized according to the NEC requirements and securely connected to the conduit on both sides of the discontinuity. When working with hazardous locations, such as those containing flammable gases or vapors, it's essential to follow the specific grounding requirements outlined in Article 500 of the NEC. These requirements are designed to minimize the risk of ignition caused by static electricity or electrical faults. In general, grounding and bonding in hazardous locations is more stringent than in non-hazardous locations. All metal enclosures and raceways must be bonded together to form a continuous grounding path. Special grounding electrodes may be required to ensure adequate grounding. It's also important to use explosion-proof fittings and enclosures to prevent the ignition of flammable substances. When installing grounding electrodes, it's important to follow the requirements outlined in Section 250.52 of the NEC. This section specifies the types of grounding electrodes that are permitted, such as ground rods, metal water pipes, and concrete encased electrodes. The grounding electrode must be installed in accordance with the manufacturer's instructions and must be located as close as practicable to the electrical service. The grounding electrode conductor, which connects the grounding electrode to the electrical service, must be sized according to the NEC requirements and must be protected from physical damage. In addition to equipment grounding, the NEC also addresses the concept of system grounding. System grounding involves connecting the neutral conductor of the electrical system to ground. This is typically done at the service entrance, where the neutral conductor is connected to the grounding electrode conductor. System grounding is intended to stabilize the voltage of the electrical system and to provide a reference point for fault current. In some cases, it may be necessary to install a separately derived system, such as a generator or a transformer. Separately derived systems must be grounded in accordance with the NEC requirements. This typically involves connecting the neutral conductor of the separately derived system to a grounding electrode conductor and a grounding electrode. It's important to note that the grounding requirements for separately derived systems can be complex, and it's advisable to consult with a qualified electrical engineer to ensure compliance with all applicable codes. Finally, it's worth emphasizing the importance of ongoing maintenance for grounding systems. Grounding connections can loosen over time due to vibration, corrosion, or physical damage. Therefore, it's important to regularly inspect the grounding system and to tighten any loose connections. Any corroded or damaged component should be replaced promptly. A well-maintained grounding system is essential for electrical safety and for the reliable operation of electrical equipment.